So today we're going to do a little review of polynomial and synthetic division. This is to prepare you to rewrite an integrand into something that's easier to integrate. So we're just going to start with a little division in general and sort of what's the process of division, because it's the same process for polynomial division, maybe with a couple little twists. So my first step is always I think about this number and I say 7 times what equals, in this case, we're just going to look at the first part of our divisor, dividend, I don't remember. Anyway, 52 in this case. I'm not so up on my division terms at this stage. But anyway, 7 times what would give me 52? And the answer is 7. And then I put that number up on top. So I'm going to put it up on top 7. And then my next step is to multiply that top number by whatever is over here. So I take 7 times 7 and I get 49. Multiply, and I'm going to write it underneath. Okay? My next step, once I have that under there, is to subtract. And when I take 52 and I subtract 49, I get 3. Next step is to bring down my next number, or I'm going to call it term, because when we're doing polynomials, it's going to be the next term. So I bring down my next term, and then I'm back up here. Only in this case, now I want to know 7 times what equals 38. And I think in my head, well, that's going to be 5. And 7 times 5, because that's my next step. So I put that number on top, multiply, and write it underneath. There's my 35. Next step, subtract. Well, I get 3 again. And then bring down the next term. And now I'm back up again to the top, only now I'm doing 7 times what equals 31. And in this case, my answer is 4. So I put that at top. I multiply 4 times 7, get 28. Write it underneath. Subtract. And then I bring down the next term. And when there is no next term, then we write as a remainder. But we're going to write it as the remainder. Instead of saying remainder of this, we're going to add it like plus 3 over 7, because that's what's left. 3 is left to divide by 7. I haven't done it yet. Okay, so that's sort of our dividing process. When we come over here to polynomials now, I'm going to divide x plus 2 into x cubed plus 4x squared minus 5x plus 1. So what I'm saying is, what's coming up is we're going to have an integral of this, and it's not a W substitution, it's not an integration by parts. Our method is to actually divide it, and it's going to simplify and make it, a lot of it, a polynomial, and then a more manageable rational function where the degree on the top is smaller, and hopefully we can integrate it. So I'm going to try and simplify this expression by actually dividing. So again, my first step, x times what is going to get me, and in this case, again, we only want to focus on the first term here and the first term there. So I'm saying x times what gives me x cubed. I don't really care about the 2 or the 4x squared or any of the rest of it right now. I'm only thinking about the x and the x cubed. X times what gives me x cubed, and my answer is x squared. So I write that up top. That's my next step. Now I multiply. So I multiply x squared times x, and then x squared times 2. And so x squared times x gives me x cubed. X squared times 2 gives me 2x. And now I subtract. And again, I'm subtracting all of this. So I'm going to subtract this, and I'm going to subtract this. So you can change all your signs and add, or you can think subtract. But x cubed minus x cubed is 0x cubed. This first piece should always cancel out. If it does not, you have not chosen the right number up top, or you made a mistake when you were multiplying. So you should always get 0 here, which means that that disappears. And then I'm left with the next terms, 4x squared minus 2x squared. Oh, that should be a squared. That's going to give me 2x squared. My next step after I subtract, bring down the next term. And now I'm back up at the top. And I'm doing x times what, but now I want x times what. I'm just looking at the first piece right there. X times what is 2x squared? And the answer is 2x, and that is what I write up top. Now I multiply. Again, 2x times x, 2x squared. 2x times 2, 4x. Subtract. And again, 2x squared minus 2x squared, awesome. That's 0x squared. That should always happen. Usually we don't write it because it just makes it messier. And then negative 5x minus 4x is negative 9x. So I've done my subtracting. The next step is bring down the next term. And now I'm back to x times what, in this case, gives me negative 9x. And the answer would be negative 9. So I write that up top, and I multiply negative 9x minus 9. Right, and now I'm subtracting. So if I subtract, you basically change the sign and add, and my remainder ends up to be 10. So at the end, I can write this as 10 over x plus 2. And this thing right here that I get for my answer, that can replace this right here. And hopefully, this right here is something that you will be able to integrate. All right, so let's try this simpler method. So some of you are like, yeah, that's the long way. What about the short way? So let's clone this page. And we'll get rid of all the mess, because the simpler way to do this is what's called synthetic division. Ooh, okay? And synthetic division works as long as you are dividing by something, by x plus or minus something. So it has to be x to the 1, and there can't be a coefficient that's not 1 in front. All right? And if that is true, you're basically going to divide by whatever makes your bottom 0. So in this case, it's when x is negative 2. So I take my negative 2, and then I divide it into my coefficients. So I have a 1x cubed, a 4x squared, a negative 5x, and a 1. Okay, here's my coefficients. 1, 4, negative 5, 1. There they are. 1, 4, negative 5, 1. Those are my coefficients. I draw my line. Your first step is always to just bring down that first number. Okay, so I bring that down. My next step is to multiply. So negative 2 times 1 is negative 2. And then, after I multiply, we add. So in our columns, we're always adding. 4 plus negative 2 is 2. And now I'm back to I multiply again. And I get negative 4 here, and then I add, and I get negative 9. And then I come back here and I multiply again to get 18. And I add to get 19. And that should be the same thing that I got before, and it is not, which tells me I made a mistake. 1. So I said I made a mistake before, and I did, right here. Hopefully you caught it. When I multiplied my 9 times x plus 2, I got 9x. I should have gotten plus 18, which would make this a 19, and would make that a 19. Hopefully you caught it and have been confused, and now I've cleared up the confusion. If not, you are not paying close enough attention. You should be working along with me. And I shouldn't have made the mistake. But so here, back to this problem. Here we are. I have this, and this guy here is my remainder. And as I try and pull what this is, you start with the remainder, and sometimes it's 0 if it's a perfect divisor. This is the constant. This is the coefficient on x, and this is the coefficient on x squared. So when I divide, I get x squared plus 2x minus 9 plus 19 over x plus 2. The same answer as what I got before. Let's try this one more time. Hopefully there's no mistakes here. Because this is one more thing we have to be careful of when doing synthetic division. Okay, so again, yes, I can do this because it's x plus 1. It's 1x is in front. So my thing I divide in this case is going to be -1. I have to be careful because I have to have all of my terms represented. And if you notice, there is no x cubed term, which means there's a 0x cubed. And there is no x term, which means there's going to be a 0x. And then there's a 10. So I always bring down my first number. I multiply -1 times 1. And I get -1 there. And now I add 0 and -1. And I get -1. I multiply -1 by -1. I get +1. I add -7 to 1 to get -6. I multiply this -1 times -6. And I get 6. I add it to 0 and get 6. And then -1 times 6 is -6, and I add to get 4. So now I have to figure out what all my parts are. This is my remainder. This is my constant. This is going to be the coefficient for x squared, and for x cubed. So this thing I have up here can be replaced by x cubed minus x squared minus 6x plus 6 plus 4 over my bottom, x plus 1. Okay, so that's synthetic division. The one thing you have to look out for is missing terms. When you can't do synthetic division is when you have something like this. I couldn't do synthetic division number 1 if I had just this, because this is not a coefficient of 1, so I could not do synthetic division. And then since this is an x squared, I definitely can't. So just really quickly, how do we walk through one like this? If you happen to get one, we have x cubed plus 3x squared. So this is a little more complicated in one way, but in another way, it's actually faster because I'm not going to have to do as much multiplying. So again, this time I'm only thinking of this and this. X squared times what gives me x cubed, and that would be x. I tend to write my thing above the term with the same degree, so since I have x to the 1, I'm putting it over the -5, x to the 1. And now I multiply x times x squared, x cubed, x times 2x, 2x squared, x times 1, plus x, and I subtract. X cubed minus x cubed, 0x cubed. Awesome. That has to happen or else I haven't picked the right number. 3x squared minus 2x squared gives me 1x squared. And -5x minus x is minus 6x, and I bring down the next term. And again, notice now I just have one more thing to do. So now I'm trying to figure out x squared times what will give me x squared. My answer is going to be 1. And when I multiply 1 times x squared, 1 times 2x, 1 times 1, now I subtract. And I'll subtract here, so I make those all negative. And x squared minus x squared, 0x squared, excellent. 6x minus 2x is -8x, and 1 minus 1 is 0. And so it looks a little weird, but this is really my remainder. I have nothing left to bring down, so I'm going to write minus 8x over x squared plus 2x plus 1. There we go. And hopefully, if this is calculus, that might be something we can integrate. I'm not sure if it is, but we have done the polynomial division, and you have what you need to get ready for the lesson on integrating by doing polynomial division.